of two boards that come from Conrad over in, I think it's New Zealand actually. Yeah, two boards here, an A2000, I see a green pin already. Now the other thing is, and that's green, I thought I'd just show you this because look at this box, there's two boards in here, all the way, airmail across the other side of the world. I'd be amazed if either of these is not damaged in transit this way. Hi, it's Gadget UK here again. Very interested to look at this board. It's the OG, I want to say Xbox, it's not, it's the OG Amiga 2000, the original generation one. So this is one of the very, very early revisions, made in Germany, West Germany back then, because it was still, I think the Berlin Wall may have still been up at that point. Honestly can't remember when it came down now. So it's got PALs, lots of PALs around the place here. 7.4 series here, so we've got the normal slot there. Everything sort of here looks the same. Yeah, still got the space for two, additional 16-bit extensions there. That is sheared. Can you see that? It's like at an angle like that. So we're going to need to do something with that. I've ordered one of those. There might be, probably is some trace damage here because that's got, it's been whacked in transit. It was just in a cardboard box as I showed you. It's got diagram in there. It's got these nice purple ceramic chips here, one of which, it might even be one of these other ones, is going to be the original Agnes. So not Fat Agnes, but Agnes before she, gained a bit of weight and absorbed some of the clock generation stuff, and maybe one or two other things, I'm not sure. I think it was primarily the clock gen stuff. Maybe some of the stuff to do with the memory side of things. There may be some buffers or something like that, or some of the logic that's exploded out into a PAL here. I want to say exploded out, obviously it wasn't originally, and then it eventually got shrunk down into Fat Agnes with the clock gen stuff and everything merged into Agnes. That's why it became Fat Agnes when we stepped up from a DIP to a PLCC chip. So yeah, it's really early, and actually the same, I don't know which one it is, one of the, wherever Agnes is on here, it's going to be the exact same chip that was used on the Amiga 1000. And the other thing in relation to that, there's a lot less RAM here, look. You've got half the amount of RAM you get on a Rev 4 2000, so it's only going to have 512k. So yeah, I've always wanted this revision. It's nice to have a look at it. If anyone's got one of these that's balked and you want, and it's got an Agnes, then yeah, I'd be interested in buying it at some point. But yeah, I'm not sure if these sockets are third-party bodgers or what. I don't know. It got an interesting colour difference there. That's got like orange print or something on it. Can you see that? And that one's got green. So I don't know, it's weird, isn't it? And green sockets, two green sockets. So maybe that was from factory like that, or maybe that was a fix. No, I think it's from factory, and it's got a factory bodge on here, look, it's got a few. Yeah, so these would have been factory fixes by Commodore. Now, for the observant of you out there, you'll notice a difference here straight away. You're like, where's the rest of the video slot gone? There's two of these on a Rev 4 and a Rev 6. We've only got one here. So yeah, that causes you some interesting problems with certain types of expansion and stuff. You could probably, not necessarily mod to add the extra thing, but you could get around it perhaps by taking signals from elsewhere and having some sort of adapter that maybe plugs into there and then goes to a Zoro slot or something. I'm sure there's probably some way around that. I mean, worst case is you could relocate things here and just drill holes in the PCB here and fit an extra connector. You could almost do it if this wasn't in the way, but obviously you'd have a lot of wires, and mind you, there's not very much using trace wires there on that side, but there may be on the underside here. But yeah, you could bodge something on there if you were that way inclined. Yeah, so I need to have a look around this and see what's bent and what's not, because look at this, some of these things have got absolutely squished in transit, and we could have some short circuits as a result. So yeah, I'll have a bit of a visual inspection around this before we power it on. May just try and just, don't know. I think what's happened here, actually, I think the traces have survived, because if you look here, they've sunk in, yeah, and the extended legs we can see here, it's just pulled out of the socket. So you know what, might not even need to get a new socket, but I mean, I've ordered one anyway. Yeah, I think I'll just desolder that at some point in this video here and get a new one on, and I'll fix the old one up, put that in my spares or something. Yeah, it's not a very good quality one, that, anyway. It's not gold plated. And in fact, that's the other observation with these. Looking at these straight away, can you see? They're all, I don't know, like some sort of metal, nickel or zinc coated or something. You know, they're not. It'll be nickel because zinc's perhaps not conductive enough. But they're all silver. They're not gold. They're all silver. Every one of those there. So that's another difference. So with your cards and stuff, you would get a better connection on the later boards because of that gold plating. Oh, hang on. Green. I've seen that there. Green, look. So, and look at this here in the light. Yeah, so it's a battery corrosion job, isn't it? Oh, joy. Let's take that CPU out. It's looking green from here, I think. There we go. It's pretty stuck in there. So it may, in the first instance, need me to remove this socket. That's probably what I'm going to end up doing, I think. And fit a new socket on. Yeah, the pins there, look at those, they're super green. Don't know if you can see those. Really green. And super green here. So anyway, I'll clean around with some vinegar. I won't just dive in and replace the socket. I'll use the fiberglass pen on some of these wires and things here. Just have a bit of a scrub around, a bit of a clean around. And then we'll power it up and see what it's doing. But after I've inspected it as well, I don't see any of the signs of damage in transit or anything other than that. Right, so I'm going to start with the vinegar actually. I've had an inspection, I don't see any other issues. Let's just get a bit of vinegar on there. Is it fizzing? No, it's not, but those pins are solid green, these end ones here. But you know what, it kind of does look superficial. The majority of the pins there are fine, and the traces have held up incredibly well on this compared to the later boards. I don't know whether it's the type of, you know, the manufacturing of the PCB here. The solder mask is just like being solid, so it is pretty minor. There's a little bit of corrosion around those two components down there that you might not be able to see, just on the tops of them, fizzing a little bit there. So actually it's not too bad, and obviously we've got corrosion there for sure. Pressing right into those pins because the greeniness is inside them. So then I'll start to just mop up what I can with a cotton bud here. In fact, let's step up to using the paper towel, which I've sort of on the underside of it. Let's just, yeah, just try and absorb what we can with this, and then I'll toothbrush it with some IPA. So there's very little coming off. If this was a Rev 4, Rev 6 now, we'd have loads of the green solder mask coming away. So it's really minor. It's really minor on that. I wish they were all that easy, really. I'd be surprised if we've got any trace damage there. I really will. I don't think, I'm going to call it now and say, I don't think there's trace damage on this. I could be completely wrong, but I just don't really see any evidence of any damage. Yeah, we've seen some greeniness, maybe one or two of the wires, but even the wires, they're solder coated. So you know what? I don't think it's going to be corrosion. This, I think it's going to be something else, like maybe just RAM. The problem is, you see, with this revision in particular, because you've only got one block of RAM. One of the things that perhaps makes this revision a bit harder, because you've only got the one block of RAM here, and it's all going to be chip RAM. You can't switch configuration around. So when you get a problem with this RAM, you see, it can kill the system completely. We've seen that before on 2000s and 500s, where you get a fault, instead of getting a green screen, you get a yellow screen, or it hangs at the grey screen, and diagnostics just doesn't even run on it because it's doing something with the data bus, I think. I don't know, so you get, like, I don't know, outputting when it shouldn't be doing, or something along those lines. Some of the times that RAM can go really weird. And yeah, the failure mode there just means that it's really hard to diagnose, and the only way you can diagnose it is with a scope or by pulling the RAM off. So anyway, it'd be interesting to see. And of course, you could have a faulty Agnes or something. We don't really know, you know, the origins and the backstory of this board here. Someone could have put a balked Agnes on it and then sold it on. Spares repair. I mean, that's me being cynical, but that's the sort of thing that certainly happens on eBay, where people put bad known faulty chips on a board, maybe more than one, and then try and pass it off as Oh, it worked alright till the battery leaked. Now in full well they've put a couple of faulty bits on it that they've used, you know, they've taken the parts off to fix something else. If I had £1 for every time I'd fall for something like that, I'd be pretty rich. Yeah, so I just got the IPA in there. That is looking so clean, that slot now. There's just one pin there that looks a little bit greeny on top, but you know what? That is incredibly clean compared to how it was. So I'll just absorb the IPA from around there. If anything, I'm wondering if it's going to be a bad trace around this slot, because that seems to be the most greenest thing so far. I mean, these traces have been affected by the corrosion, certainly some of the ones up here, but the solder mask coat's still there, and the solder mask paint. So, I don't know, I've got a good feeling this might just be nothing more than a bit of corrosion, because you see, the thing is, no one's really cleaned this up either. It's no good sticking diagram in there when you've got this to deal with, these green pins. That's never going to work for you. So there might be nothing wrong with it. It might be like, stick this in and suddenly it boots. I wouldn't be surprised. I hope not, because he sent us all the way from New Zealand. I mean, alright, it gives me an interesting thing to look at, but I'll be honest, I'm more interested in things that are faulty rather than things that just look a bit dirty. So yeah, we'll just have a clean with the fiberglass pencil here. They're really bad. I'm going to go straight in with the IPA here actually. Yeah, so I would tin anything like that that's, you know, you've scratched, but you can see they're nice and silvery now, look. Obviously the inside here is, you know, where you need to do more work as well. And in fact, let's just give that a go with a brush now. I'll give it another go with vinegar and then IPA later. And, you know, tin up those legs on the end, it'll be good as new. And probably outlive the rest of the machine. These 68,000 CPUs, they seldom die, do they? I've mentioned that a few times. Just recently, Sparks UK was unlucky enough to have one of them die. And I don't believe him. I'm sure it's not dead, but yeah, no, he tested on a few boards and said, yeah, it's definitely dead. He had one of the ceramic ones. You know, they are pretty rare. I don't know why or how it died. It could have been static handling or anything, really. It could have had a, you know, been in a system where it had a prior fault, and maybe the failure of it was something to do with the fact that it was the ceramic version. I don't know. But like these plastic ones, the PDIP ones like this, I've never had one fail ever. So we'll get this in, connect up some power, and give it a try. Right, let's get the power connector on. So let's just make sure it is the same. Yeah, it is the same. I'm sure it's the same. And I've got video connected up. Just make sure these chips are in okay. And the ROM, where's pin 1? Yeah, these ROM sockets, it's got pin 1 mark in there. They've not got the semicircle. And then of course we need this back in. That's it. Switch it on. And switching it on. Just feeling the tops of things here, nothing getting hot. It looks like we're getting synced, doesn't it? Hang on a minute, just touching around things as we're getting some behaviour, so you know what, it could just be a bad connection somewhere. Mind you, this is diagram. Oh, hang on a minute. Do you know what? I think I spot a problem straight away here. Isn't this got the same ROM problem that the early... I could be wrong. You might have fixed it on here. Yeah, I was going to say the early ROM problem where... Was it A17's not mapped properly? This might actually need a kickstart ROM. Yeah, the fact that someone stuck an EEPROM in here, that might work on the later, well, it does work on the later boards. I'm not sure about this one though. I think we're going to need a kickstart run there. Let me see if I've got a kickstart run to hand somewhere. Yeah, I think I've got 1.3 here. Yeah, I can see it in the red ink. Let's just get 1.3 on. Let's just power that on. No, it's giving us a black screen. So you know what, I think there is some sort of issue there. Let's just make sure it's on the right channel. AV1. Yeah, I've got sync, because otherwise we wouldn't have the 3 dots there. Just pressing down on that CPU. Yeah, but you know, I see no damaged traces or anything around here. So just switching it off. I think what might be an idea here is just to reseat 1 or 2 of these things. CIAs, well, let's do what we should do really is swap these around. I think the single wipe sockets, you know, this might be the issue as well. There's another reason why reseating them, certainly when you've had corrosion, is a wise move. Yeah, just making sure they are the same part number there, not doing something crazy. Let's try it again. Yeah, we've still got a black screen. Now I hear what you're saying, voltages, let's just check, make sure we do have 5 volts here. Just in case something on here is getting hot. I mean, I can't, it's not one of the customs if something is getting hot. But let's just make sure we're not losing the supply or something. Let's just test one of these 7.4 series if I can find one. That should be, yeah, I've got the connection the wrong way around, but yeah, minus 4.7. 4.7, that's alright, because there's some voltage drop on this. Yeah, that's right, yeah, it is 4.78 volts or so. So we don't have a supply issue, none of the main chips are getting hot or anything here, and if they were, we'd see that voltage lower, so that's not the issue. So the next obvious thing is to just carefully take out and reseat these chips as well. It's interesting to use turn pin sockets here. I mean, that makes a mockery of all the people in the past have gone, don't use turn pin sockets on a board, they're only for upgrades and mods. Well, Commodore used them themselves when they built these boards. I think it was that Hans Campbell guy who said that to me. He says, you need to be an expert like me. I've got all the expert tools and experience and I know how to fix these things. Don't stick turn pin sockets on. Yeah, thanks for that, Hans. Yeah, it looks alright. Socket looks alright. So let's just carefully get that back in. Let's just see what the part number on that is. 8367. That's Agnes, I think, because it's got a weird oddball part number. That's Agnes. 8367. I mean, the positive thing here is if it's a clock gen fault, it's not going to be that, is it? Because it didn't have clock gen at that point. So let's just try it like that. So obviously I've got must have Paula and Denise back there then. Still just a black screen. Now I'm assuming that this ROM should work on here, like maybe they didn't do something, I don't know, you'd hope that they didn't do something really weird with the ROM socket there, making the mistake where ROMs from other systems won't work on it, but I don't think so, I don't think that's the issue. I could just try reseating that again. In fact, I've got another CPU, let's just take this out. I've got the one here from one of my other 2000s, and it just tends to flow on this bench a lot while the 2000's on the bench. So yeah, we know this works. At least this will rule out CPU being the fault, but it could be the socket, could be traces, but everything looks really good round there if I'm honest. Yep, still just a black screen. Well, you know, something did cross my mind, is like maybe the video port's weird here. Like maybe my video cable won't work with this or something. Like now we're probably seeing a yellow screen or a green screen, and that's just a thought I had, because I do know there's some differences here with that video slot, and there could be some damage related to that there that mean that we're missing something on the video. But anyway, we've got sync, we are seeing a black screen, so you know what, I'm not going to think about that too much more just for now. Let's now try and take out these nice purple ceramics. Again, the sockets looks fine and the pins look fine. Yeah, just inspecting to make sure all those pins are in. Yeah, we've got no folded up pins or anything. I'll try that again. Yeah, just a black screen still. So we're not getting very far with this, are we? I think at this stage I'm going to go back to using diagram again. Now we've certainly ruled out that, well, I think we've ruled out, there could be, the thing is, could be a fault with this, and because there's a fault with this, we're not going to get the right behaviour anyway. But now we could have two issues. Now we could have the ROM issue and a fault, if that makes sense. Yeah, so you see, like, diagram is doing something. It's doing more than Kickstart was doing. Well, no it's not. Hang on, yes it is. Let's try it again. That's an interesting one, isn't it? What I might need to do is get the serial port connected up. I mean, it's interesting that little loop goes round and round and round there, look. Let's just do the test. The other thing is there's no buster on here either, is there? That's the other thing that Commodore changed. They put a load of the logic from the PALs into the buster chip. So there's no buster on this. Well, it's no wonder Conrad couldn't get this one working. It's mysterious, isn't it, to say the least. I'm just going to reconnect that video connector, because I did notice some dirty pins on that, but I don't know. It's like, what's this stuff here? You know what, it could be bad RAM this, because just feeling the tops of these chips here, they're just like lukewarm. And you go over here, one or two of these here are quite a lot warmer. Just feeling the 7.4 series and PALs and things around the board for temperature, just see if I can find anything that's getting lukewarm. You know what, maybe I'm imagining things with the RAM. I think all the RAM's the same sort of temperature, to be honest. Right, so about 15 minutes in, I tried a few different things. I had the TL866 out and some GALs to hand, so I swapped the one here for the CAS. I'm not sure if that one is related to it as well, but I swapped those out. Same behaviour, so I put a tick on those, put the original chips back in. And then I started scoping things, looking at the clock gen stuff around here, the 7.4 flip-flops. I can show you some of that in a minute on the scope. But then I went back to just looking at the stuff up here, 244s, 373s. I saw a weird signal on one of the 373s. And then I thought, let's just have a look back at the CPU. So looking at what I think are the data bits, the first ones up here, pins 1, 2, 3, 4, 5, I think. And they look weird, I'll show you on the scope in a minute. But if I just measure on resistance here, and what I noticed is that the fourth one I think looked weird. And it was short, well, it seems to be connected to the third one. If I measure between the first and the second pins here, 20k. Between the second and the third, 15k, going up to 20k a little bit there. And then these two here, the next ones, going at 180 ohms. And the next two, 15k. So between the third and fourth pins there, I think it's pin 3 and 4 actually, we've got 180 ohms, so we've got two data bits that are sort of shorted. Now it could be one of these resistor arrays here that's broken or got some corrosion, you know, some conductivity. It could be corrosion between the two pins on the underside of here. And nevertheless, I thought I'll show you how I worked that out. You know, let's just scope it. Let's get the CPU back in. And if you keep an eye on that, so I'm booting up, here's pin 1. So straight away some contention issues or something. Can you see the logic level? Look at the ground. It's not going down to ground. So that was the first thing. That one's not going down to ground. Pin 2. Pin 3. Showing next to nothing, look. And this is one of the ones that's got 100 and some ohms to the pin next to it. Look at that one. A little triangular mountain range, look. Nevertheless, pin 3 is almost flatlined. Pin 4 is showing the little triangular peaks there. So I need to go and look at the pin out actually, just to double check. But it's a clue. I'm going to get a load more vinegar around there, just leave it soaking for 10 minutes actually, just on the off chance that something has joined up. I mean, it could be a clue that something else, you know, on those two data bits are shorting. So for example, these are probably on the data bus, so I could just remove those to see if the resistance goes. You never know, maybe both those are balked. Could be something like that. I tested it without this PAL in, same behaviour. So, was it the same behaviour? I think it was actually, so I don't think that's causing the problem. And as I said, clock stuff up here, I see, you know, the 7.09 and multiple, you know, 14.18, and I saw the 28 megahertz clock and 3.57 something PAL. frequency there. So I mean, I haven't checked every single pin, everything around there, but what I do know is the flip-flops are flipping and flopping. So I don't know, it's a bit of a weird one, this. I just hope it's not something really obscure like a problem with this. But anyway, we've got a clue here. I actually think that this is the issue. I think the CPU's not able to get off the mark properly. Right, I think there's more going on than meets the eye here. I don't think it's about corrosion here. I left it overnight, and the resistance there's changed between pins 4 and 5. Yeah, the fourth data bit there is flatlined. That's the main thing, and then you saw the like little peaks that go up and down on the next pin, because I think there's like D0 to D4 here. So D3 is flatlined. Fourth pin up on the side here is flatlined. I just tested connectivity. I removed the CIA, as you can see that, tested without, because obviously got data bus connectivity there. Same behaviour, same problem. So I just tested connectivity from here, and it goes to here and here. This is a 373, this is a 244. I tried piggybacking this 244, exactly the same with the 373. But nevertheless, because it goes here, and there's like, I'll show you, the middle of that chip there is all worn away. It's like, I don't know, it suffered heat damage or something. I think that's got red hot in the centre. I think that 373 is booked, but this may be booked. It could have killed this, I don't know. This is the Agnes. So I'm going to remove that 373 and get a socket on, I think. I mean, I could snip the pin. I've seen people do that before. It was a technique I was shown back in the day, but yeah, snipping pins. When you snip a pin, you know, you commit to destroying that chip, really. You can solder the pin back on, but it's never going to be the same. It's got to be something like that. I mean, it could be some address decoding going wrong somewhere. Yeah, which means that we've got contention, and then for whatever reason we're always getting a problem with that data bit, but I think that's really unlikely. The other thought that did cross my mind is this real-time clock chip. On 4000s I've seen this, where this clock chip goes pear-shaped and does weird things to the data bus. It's like, even though it's not controlled by its output enable, you know, it's not enabled, it does stuff to the data bus. Maybe one bit on here is failing. I mean, I can test connectivity there as well, and let's just see if there's any difference there. But I don't think it's about corrosion around these things here. I really don't think that's the issue. I think it's got a failure. It could be the corrosion originally caused a failure. If we go around the real-time clock chip here, I'm pretty sure the first 4 or 5 data bits go to it. Look there. So you know what, it could be that. It's just that mark on top of that there that's making me think it might be that. And obviously there's 244 here somewhere. There. So yeah, CPU data bus connects to this and the 373. This is the data path on a 500, effectively. You know, your 2 latches and your 2 244s. The interesting thing is it's got 244s, not 245s. I always thought there were 245s here, because you know, the difference, 245s are bi-directional. Yeah, 244s are a one-way street. You know, a buffer. And it may be that the reads are done through the latches and the writes are done through here. That's perhaps why we've got the same things joined. So if you had just 245s, then you need the data to be there in real time. The thing with these latches is, you know, data can be latched in there and then read back on a different cycle. You know, i.e. that maybe the Agnes is then doing something else when there's something here. Or something like that. Yeah, so it's never easy to work out when you've got a problem like this. You're thinking, do I remove that, do I remove that, or do I remove that? And how do we know any of those are actually the issue? Right, I've got a plan of action, I think. Really hard to get those off. There we go. Let's just move that out of the way. What I'm going to do is desolder the pin here on the real-time clock, and try and just move the pin around in its hole until it's not joined. Yeah, and then we'll see if the problem has gone away. And then we'll do the same thing over here on 373, and then maybe the same thing on there, until the flatline scenario is resolved. Because in theory it should boot from the ROM, we should see some proper activity there. So let me just see where it is. It's on this side, isn't it? So it's 1, 2, 3, 4. Yeah, fourth one down on the left. I'm just going to just mark that. 4th one down on the left. 1, 2, 3, 4. And likewise, we'll just do the same thing on the other 2 chips here. Yeah, so on the 244, it's the 3rd one on the right side. And on the 373, the 5th pin on there is still a problem as well, by the way, because that's got a triangular peak to it. Yeah, and it's that one there, so it's 1, 2, 3, 4, 5. Yeah, 5th one up there. So again, we'll just stick a red mark there. I'm going to start with the 373 actually, because it's got, oh, let me show you. Yeah, these things are really useful on a bench because you can stop them going down the wall. And hopefully you may be able to see, if you just look at the print on this, can you see in the middle of it, it looks all faded, and the one next to it isn't. It's like the print's worn away. I think that's heat damage. I think that has got incredibly hot at some point. So, yeah, I just need to just work out which one it is. Yes, it's the 5th one up there, and it's to flip it over. It's going to be the 5th one down on that side. There. Pins are bent over, which is always super annoying. And then inspecting with magnification, I'm just going to try and snap it off the edge. Have a bit of a wobble with it. Yeah, and I think this is going to be the problem with this. I think that's still joined. Yeah, I can see we targeted the right pin, because on this side here, there's a little indent there where the solder has sort of been removed. But because it's not desoldered properly on this side, this is the thing, it's free on the bottom side, not free on the top side. I'm just going to add a tiny little bit of flux. Yeah, and I'm just going to heat that pin from the top side here with the braid. Just see if we can mop up that little bit. Yeah, and that is now looking kind of free. But you know what? That's not going to be not making a connection. Yeah, the problem is with these is, like, sometimes you see the pin can be in the hole like that, and let's say this is the flat part, the spade of the pin. It can be like that. So when you solder it, it's no longer, you know, in the socket. Sometimes the spade part can be pressed flat against the circular pad here. So even though you've desoldered the pin, yeah, it's still making a connection there on the board. Yeah, and this is one of those pins. It's flat with the board, it's flat with the pad. So despite the fact that that is desoldered, it's still making a connection. I mean, you can cut traces and things at this point. I really don't want to start cutting traces. I think actually we just take that chip off, I'll switch the desolder station on, and we'll just remove it. It's far easier than cutting pins, cutting traces. Well, it's not easier, it's just better. I don't like cutting traces, don't like cutting pins. So I'll free it up with hot air, I think, but we're going to have to be careful because it's that type of board that will damage really easy with too much heat. Right, they're all desoldered. Just try and snap them off the edges. Yeah, they're either already free or they're not doing anything. I'm inclined to think they're not doing anything, but there's loads of solder on the top side still. Yeah, there's still loads of solder there. So yeah, I'm just going to tilt the top side down, get the extractor tool onto the chip here. Most of the solder's off actually, just looking at this. I can see the light shining through. So yeah, this may come off easily. Anyway, I'm holding it from the underside. 405 degrees on the hot air here. There's a circle around, I want to try and avoid delamination, because it takes quite a while for it to get up to temperature. And I'll start to zoom in a little bit, focusing on where I believe the ground and BCC are, which right now I can't tell which way they are actually. There we go, so that was easy. That didn't take long, did it? Several seconds, and hopefully you can see there no pads or anything like that. So that's off. Now it's not going to boot, it may not get as far in the boot process now, I may get different behaviour. Yeah, so the key now is just to see if we've got any more signs of life on D3 and D4. It'd be really nice if that was the issue. I've got the feeling it's going to be one of these red herrings where that mark, the fade on the top of the chip, you know, the part number just worn away, like it looks like it got hot. Maybe it didn't. This is often what you find with something like this. You start to follow something down a rabbit hole and yeah, seemingly make no progress. We may still have the exact same problem. Right, so we'll just give that a minute to cool down and we'll connect this back up. Just make sure there's no solder. Oh, there's a few particles of solder on here. Actually, I'll get these bits of stuff off here. And let's switch the power on. Just see if we get any different behaviour. No, it's looking exactly the same, isn't it? Exactly. But then again, if that chip's not right, you would get exactly the same behaviour. Yeah, and if I probe the data bus again, so that's the second data bus pin, that's the third one, this one was flatlined. And it's still flatlined, look, so it's not that chip. And the next one up has got the little triangular piece. So you know what? That solved nothing. So we're still questioning, is it that or that? It's so hard to know which way to go with this. You see, part of me's thinking battery, yeah, real-time clock chip, maybe that failed. But you know what? There's no corrosion around that, so I'm like, how would that have failed? It could be the corrosion here killed something that's connected to that. I mean, there are other things, obviously, that could be at play here. Like, for example, one of the Zoro buffers here. Maybe I should just check those. Because that's sort of the Occam's razor, you know, someone put a Zoro card in, you know, and there was a little bit of corrosion around these things, but... Right, so on continuity test again, let's test from the fourth pin here to around here. You know, I was sure there should be a connection here, actually. I think what I'm going to do is just to clean the sides of these up, because I don't think I'm making a very good connection. So I think we've got a combination of 244s and 245s there. Very similar, if not identical, to the later Rev 4 and Rev 6 boards. You know, the 244s are going to be on address lines, buffering address lines, 245s buffering the data bus, and maybe some of the other like bus protocol signals. Talk about maybe things like UDS and LDS and DTAC, etc. This still looks very green here, by the way, these pins. Yeah, there we go. So, this is the thing, you know, you start looking at data bus, you can start going off in different directions here. Like, could it be something here? Well, they're not getting warm, but again, the print is completely worn off on that chip. But not this one, not that one, not that one, or that one, that one. So, is it that? I don't know. Yeah, I think it could even be a multiple failures thing, but let me zoom you in. Yeah, hopefully that's focusing enough, but if you look at the print here, it's all worn off. This one it's not. But, I don't know, I'm thinking the battery's probably done that, because there's like hardly any print on this, you can't even see what that is. It's the same with one of the chips over there. So, even though the board has survived pretty well with the corrosion, the surface of some of these chips haven't. So, I don't know, do we remove that? Maybe I should start cutting pins. You know what, I am going to cut the pin. I could just join it back up. Otherwise I'm just going to be desoldering everything here. Yeah, so it's the third pin along there. Yeah, so I'm going to carefully come in and try and snip that third pin. Right, there we go, that's snipped. Where's the thing here? The key is being really careful to try and avoid damaging the PCB. It's just an LS245 this, you know what, I could just replace it if we think this is the problem. Right, that's now out of circuit. Let me scope it again. Ah, it's behaving totally different. I think we fixed it. Yeah, I think that's it actually. I think that was perhaps a good call. I don't know if I just power cycle it now. See, look. Hang on. That's the third pin. Fourth pin, look. It's now not flatlined. I'll just power cycle it again. There we go. There's the Zoro data bus. Zoro data bus buffer. And the one that was triangular, it's still triangular. So you know what? I think that's going to be the same problem, the same chip. So you know what? I don't feel bad about cutting that pin at all. If we have a look now, hang on, fourth one. So this is the fourth one. So yeah, you can see we're getting different behaviour now. The video is not like doing the scrunchy up stuff. We're getting some flickers and things. It's definitely different. Right, so I'll get that. Oh, we got a greenish screen there. I'll get that buffer off. I mean, technically we could cut it off now. We've cut that one pin, but yeah, it's just hard cutting chips. I try and avoid it. Yeah, it was risky cutting that one pin. It's better if I desolder it. So let's just disconnect the power stuff. I'll report back in a minute. You've seen me desolder the other chip there. It's going to be exactly the same with this one, and I will free it up with hot air if it doesn't fall off at the end. Yeah, there we go, it's off. Yeah, and I did just drop the chip on the floor there. In theory it should boot without that. Oh my god, it's a bit dirty under there, look at that. Could that be the problem? I don't know, it could be. It looks pretty furry under there, doesn't it? This is the problem with corrosion jobs though, you know, someone's cleaned this up a little bit before it's got to me. Maybe they've cleaned it up a lot. And yeah, stuff like that, you're not going to see. Yeah, inspecting around that though, all the pads are alright, the traces are alright. I think though, I'm more inclined, you know, just want to test this now, see what happens with the data bits again. One of them we know we've fixed by cutting the pin. It's just a question of have we fixed them both, and will it behave any different? We're probably going to need to get that 373 back on though very soon in order to see whether that has solved the entire problem, if the data bits are now alright. Yeah, we got a completely different behaviour again there then. I'll scope that in again. Yeah, scoping the fourth data bit, activity, fifth data bit, activity, that's it, that's fixed it. We're still getting a black screen, but if I show you now, if we go, so we've got D0, D1, D2, D3, D4, they're all alright. And that's the next pin up there, that's fine. So we've now got no issue with D3, I think it was, or D4. Yeah, the first three bits, D0, 1 and 2, were all alright. So yeah, it was that, by the looks of things. This one could have been faulty because it had the same sort of heat mark, didn't it? Maybe this shorted and got really hot, and that's why the heat mark was on that one, and then this one failed as well. So you know what? It was a good idea removing that. We'll get a socket on there next, I think. I'll do that one afterwards because I think right now we should be able to test and get a bit further as long as we've got 373. Without that 373, all bets are off because I think your chip RAM interaction is not going to be working correctly. And not just chip RAM, Agnes interaction probably. Right, so let's get this socket into position. There we go. Perfect. That was just from obviously desoldering earlier and then just pulling off with hot air. Straight on, without having to do anything with the holes. I'm just thinking about the consequences of not having that Zoro data buffer on there, and I think we should be alright. Let me just heat like this. Yeah, I'm just pressing the chip up, or the socket rather, not the chip. And straight as I'm going to get that, I think that's pretty straight. So I'll just commit to soldering the remaining pins. Yeah, using these bits of solder that I've got that I just want to get rid of. It contains flux, this, it's, you know, multi-core solder. Pin 1, pin 1. So, pin 1 at the bottom again. Both CIAs back in. So I'll just get an LS373. Right, I've got a brand new 74LS373 there. Pin 1 is down towards the bottom here. So let's get that into socket. So other than this missing at the moment, I think we should have enough, hopefully, for this to boot. I don't think this at this point would cause a problem. It would with Kickstart, but we're using Diagrom. And let's try switching it on. See what happens. Yep, it's still not working. Hang on a minute, that 373 is not on the socket, I don't think. Yeah, its pin's squished out. That's it. Just to reinforce that a little bit. Let's try that again. I've noticed this before with these 373s that I've got. The pins, or the corner ones, I'm not sure if it's like, yeah, it's pin 1 in this case, isn't it? Ah, there's no pins hanging out this time. Let's try that again. Please go something different. Well, that's different, but it's not right. It's just different. Yeah, the data bus is alright now, so you know what, we turned a corner. I think what I'm going to do is just, let's do the obvious stuff. Let's just clean here and get a socket on. Yeah, so everything looks good on the top side there. So we'll get another socket on. Right, I've got 74LS245 here. And that's in. Yeah, it's been reused, that chip actually. It was tested in a few different things in the TL866. It was tested in the Mini Pro there. But anyway, that's in. Pin 1's the right way around. So let's connect up power again, just see if there's any difference in behaviour. I'm not expecting the difference in behaviour, if I'm honest. I think we do have some other issue to deal with as well. Yeah, still the same weird stuff going on. But we haven't got the white stuff with the screen going all distorted and stuff here. We're just now kind of just getting stuck. Just pressing around things here. Let's press around the CPU maybe. At this point I should perhaps remove those CIAs again actually, now I think about things. And my next random direction change was to get Kickstart back in. The reason being is I still think that this has got a problem with A17. I think on these early 2000 boards it's probably the same as the early Rev 5 and Rev 3 A500 boards, where A17 and one of the other pins were flipped around. And with this in, Kickstart is actually booting. Yeah, you've got grey screen and then white screen, grey screen, white screen, grey screen, white screen. The grey screen is doing the memory test. So you know what? I think we've got a chip RAM fault perhaps. But I think the problem I've got right now is it's about ROM sockets, isn't it? This is not going to boot properly in here unless we remap A17, I think. Now I may have a socket somewhere for that purpose. Let me just have a look. Ah, here it is. Yeah, here it is. I knew I had something like this. A500 JEDEC. So what you can do is two sockets that transpose the, and I'll stick it up there, what you need to map. We've covered this before. You know, there's a couple of wires there to flip a couple of pins around, and then you can stick an EEPROM into this. I'm assuming I got the pin 1 thing right way around here. So if we get Diagrom into that, hang on. Carefully. Like that. And then get this into there. Let's just try. We may get a wee bit more information because it wouldn't have been booting properly at all with that ROM the way things were, I think. I could be wrong. We may find this does nothing. But I think it will, because you know what? Kickstart was getting further than Diagrom. Oh, look at that. What a surprise. There you go. So follow your instincts. Follow your instincts. Yeah, we can have a chip RAM fault now, aren't we? It's seemingly pretty obvious to me. I'm pleased though, because you know what, it's not taking too much time this, I've flying through this. So it's showing the right chip RAM here. Let me connect a mouse up. I'm getting a bit nervous now, because now I'm thinking maybe there isn't a chip RAM fault. Why doesn't Kickstart boot? This is going to be a painful one if it's not a RAM fault. Please let it have a bad location somewhere. Oh, hang on. Address error detected. I think that's normal actually with this version of Diagram. Oh, hang on a minute. Diagram doesn't solve address faults, does it? Or detect address failures, I think. Yeah, I'm getting vague recollections of this issue. So I think we need logic in there. It probably is a RAM fault. This is the thing. Diagram. Oh, come on now. Yeah, Diagram is going, your RAM's alright. No, it isn't. No, it isn't. It's lies. So the thing with Logica is, well, its memory test is a lot better than the older versions of Diagram. And I think that problem with Diagram's been fixed, by the way, in later revisions, but the version of Diagram he had on there is perhaps the same one I'm using, which is an older one. So let's power cycle, power on. Yeah, so we get coloured flashes and things just like we do with Diagram. I mean, the majority of chip RAM must be alright, because you know what, getting a display, when you've got display like that, it tells you that it's probably alright. So maybe the chip RAM isn't the issue. So we're going to do 2000. Let's do CIA test. Precision timer. Hang on a minute. Timer interrupt not received. Oh, it might be missing. Yeah, it's missing the tick signal, so that's probably right. Oh, hang on a minute. Can't get out that now. Can abort them, can't I? Let's just go back. Memory test. Chip memory test. Well, I don't know, it's not RAM, is it? So, I don't know, so I'm really confused now. We know it's not the RAM, but why doesn't Kickstart boot? And hang on a minute. This is fixed, think about it. It goes grey screen, you know, it goes light grey screen, dark grey screen, then it should go white, yeah? I've seen the same sort of thing in a different way with later Kickstarts, and it's this tick. We haven't got tick from the power supply. Each of the CIAs here has a tick input, you know, a time of day input, a clock that needs to go in there, and it's 50 Hertz reference from the power supply. I don't know where it goes. It's probably the grey pin on the end there, and yeah, the ATX power supply doesn't provide that. Yeah. Now on the later boards, there's a jumper to switch between whether you take it from VSync or from the power supply. I'm not sure this board has that, because there's two jumpers. There's one here. It could be that one actually. Now I think about it, it's right next to CIAs. I bet that's what it is. Let's just switch it off. Let's just turn that jumper to the up position. That might then take a tick from Agnes. Well, in this case it's not Agnes, it's going to be from one of the 7.4s or something, because the clock gen's done differently. I think, but having said that, Agnes does produce VSync, so you know what, it probably comes from Agnes. Switch that on, and let's just see if the time of day stuff passes. If it does, then Kickstart will boot, and actually we've fixed it, I think. It just needs a bit of a clean up and a final test. Yeah, I could have spent quite a while thinking and theorising what the fault actually might be, when if you just look at the evidence you've got, well, time of day is the first thing here. That's probably the issue. Oh look, time of day's alright now. I changed that jumper. That was a good bit of guesswork, wasn't it? So I reckon we get Kickstart in and it's going to boot. Yeah, so absolutely thrilled to bits that we've managed to get this ancient original Rev 2000 fixed here with not too much work actually. Most of the work's just been spent actually desoldering. It's the time taken to desolder those two chips, and I think it was a good idea removing that, because you know what, I think that was bugged as well. That's what the heat markage was on both of those chips there, even though they weren't hot whilst testing. Now, because now we've got that ROM, we don't need this Tower of Insanity here, so let's just see if we can get that out. It's useful to have something like that when you're working on these early boards. It can just save you so much grief. Some of the ROMs, you know, the modern ROMs, like the Boobit one for example, has got a jumper on there. You can set that to put it in the old configuration. Great, light grey. That's it. It hasn't reset. It was that reset. I mean, like, seeing the reset, and it was the reset thing that was going through my mind, thinking about the time of day stuff, going, oh, hang on a minute. That's all it is. There you go. Fixed. Woohoo! So the video is getting a little bit long there. Come back in part 2, hopefully, and you'll see there's a number of other things we need to do to this board. There are some more problems with it. There's some modifications, small ones, that we need to do, and we need to test lots of things out on it. Thank you very much to Conrad Larson for sending this. It was really interesting to look at. I hope you found the video interesting. If you'd like to support the channel, please do consider the Patreon and Coffee links down below. We've lost quite a lot of support over the last few months, cost of living and stuff. It's like I haven't had a pay rise in my job for 2 years now. It's all post-COVID stuff, the state of the world, the economy and everything. And please remember that half of my income is Patreon. So it's like, you know, this is why I spend every minute of every day working. I work 7 days a week. So if you can and would like to support the channel, just for $1 a month or something, it's much appreciated. I'll catch you in the next video.